So we just want to take a minute to thank you all for being here this morning, and welcome to the 5th in our series of water loss control webinars. They are sponsored by the Tennessee Department of Environment and Conservation. And today we're going to be talking about real losses. This is the last in our series of technical trainings. So if you've participated in all of them, we really want to say thank you, and we hope that you found good value in learning about your water loss control program, from developing your team and setting goals all the way now to controlling real losses. And again, we just want to reiterate that this project is funded by the Tennessee Department of Environment and Conservation, and this project wouldn't be possible without their vision and, of course, their funding. This training series and the individual technical assistance that's available is all free of cost to anyone attending, and that wouldn't be possible without TDEC support. We know that water loss control is an important issue nationally and to Tennessee in particular. And of course, it's near and dear to us at the Southwest Environmental Finance Center. So again, we wanted to thank TDEC and thank you guys for attending. A little bit about who we are for those of you that haven't attended any of the training sessions. For those of you that have, these are going to be repeats, but we'll go through them pretty quick. So the group that I'm with is the Southwest Environmental Finance Center, and we're a multidisciplinary team. We have engineers, we have water resource folks, we've got training and teaching, computer programming, GIS mapping, accounting, rate setting. We've got a wide variety of backgrounds. We are a part of the University of New Mexico that is located in Albuquerque, New Mexico. But today, neither one of us are actually in Albuquerque. So James is on the West Coast and I am on the East Coast, and most of you are in between. So we're trying to cover all the time zones today. And in the center of our screen here, you can see our mission statement. And it is: the Southwest EFC promotes self-reliance through innovative training and assistance focused on actionable results. And that really is what we want to be about. We want to provide you with the tools and resources to be able to tackle, the challenges internally, and to not be dependent upon, a group like us to always solve the problems. And so, we really do believe in that teach a man to fish approach rather than fishing for them. So that's why we offer the technical assistance. We want to help you answer any questions, try out some new tools, maybe work on some spreadsheets that are, giving you some headaches, and you don't want to give up on them, but you also don't want to keep banging your head against the wall. So those are the things that we want to do and be able to help you with. Right now, the Southwest EFC is a team of about 15 people, and we are growing, so that number is changing rapidly. So we're excited for our growth, and hope to be able to continue to work with you all in the future. So what does the Southwest EFC do? We focus on helping systems, water systems, wastewater systems, to answer questions in the technical, financial, and managerial areas of water and wastewater operations. We provide training on a wide variety of topics, and this specific team has most recently focused on training in asset management and water loss control. And the two of those do go hand in hand, and that's something that will be really clear after today's session. But we do assistance in a wide variety of areas. So if you find that you're interested in learning more about asset management or rate setting or a whole wide plethora of topics, please reach out to us. We'd be happy to help you guys. So a little bit about me. I found pretty early on in my college career that water was really where I wanted to spend time. I'm a chemical engineer by training, but found that I thought I'd do plastics, and then found that when I got stuck in a wastewater treatment plant as a college intern, I thought it was going to be awful, and ended up falling in love with it. So I've been in the water and wastewater industry for most of my career. But not only in my career do I enjoy water, I also enjoy it in my personal life. So you can see me and my family on our boat on the Tennessee River, vacationing at the ocean. And if those two aren't enough, we jump in the pool. So all of that's kind of coming to a quick end with the weather changing in East Tennessee the way it is. But that's all right. We had a great summer, and we really enjoyed the water as much as we could. So, so I try to make it, important in all areas of my life. And then with the thunderstorm we got this morning, I told James my basement got wet. It was coming in my door. It was blowing that hard. So, maybe I don't enjoy water all of the time, but as much as possible. So James, tell us a little bit about you.
Yeah, I've been with EFC for 5 or 6 years now. I grew up near water, from the Pacific Northwest up in Seattle. For some reason, I live in the desert right now. I'm one of the few people trucking around there with a sailboat, which I get to use about once every 3 years, it seems like. Um, I've come into the water world sort of sideways. I was a lawyer first and then spent about 10 years in operations management before I made the switch to engineering. In my spare time, I spend a lot of time building guitars. Music is my therapy, keeps me sane. In my work life, I spend most of my time, as Dawn mentioned, doing asset management, water loss control activities. Spend a lot of time doing GIS mapping and pipe break analysis and things like that. So glad to be here today, and thanks for joining us.
Thanks, James. But just a reminder to ask questions as we go. We're happy to address them throughout the training sessions today. We don't give a specific time at the end or in between sessions to ask questions. We just want you to ask as we go. So make sure you use that chat feature if you have questions. And while I am training, James will monitor the chat and ask me any questions that come in and vice versa. So we will always be kind of monitoring that chat. So feel free to use it at any time. And with that, we're going to get started with today's training. So we always want to take a minute to ask how it went with the last session. So the last session, we were talking about apparent losses and how to control apparent loss. And so we have just a couple of questions that we're going to ask about how it went. If you weren't involved in the last training, there should be an option that's not applicable, or if you kind of know the answer anyway, feel free to go ahead and select the answer that best applies to you. No one's being graded. This is just for us to have a little bit of feedback and to see kind of how the activity went, if it was usable or if it wasn't. So that's just information for us alone. So James, if you wouldn't mind to go ahead and start the poll. So this one is a multiple choice. First, pick yes or no. And if you pick yes, then you can answer with any of the options below it. So did you identify areas where you may be able to identify apparent losses? And if so, select which type of losses from the list below. So yes or no, were you able to identify apparent losses? And if you were, was it in data handling errors, customer meter inaccuracies, and or unauthorized consumption? All right, let's go ahead and close this one. So all of you that did share said, yes, you were able to identify apparent losses, and some of you in data handling errors, whether that's meter readings or customer billings, and then some of you with your customer meter inaccuracies, and some of you with theft. So that's really exciting to see and hear. And what that tells us is that when we kind of think about where's that water going, maybe there are places where we just haven't named it yet. So that's really great to see and hear. And thanks for sharing. We've got a couple more questions here. So James, if you want to go on to the next one. This is a simple yes or no. Were you able to analyze any of the data associated with those possible losses? All right, James, I think we can wrap this one up. Uh-oh. Did I lose you, James?
Nope, I'm here.
You're there. Did I get frozen up?
I think you've got frozen. So we've got a little over half saying yes, they were able to do some analysis, and the others, about 40%, not yet, which is also good because that implies that they're going to get to it.
I didn't give them a no option.
No is not an option here.
I was encouraging them that if they didn't, that they should, not yet, but they will.
Exactly.
So I'm going to turn my video off. I am still getting some storms, so I just want to play it a little bit safe. So I apologize for that, but gonna see if that maybe helps me. So I think we have one more poll question, James, if you don't mind to run it.
We do indeed.
So this is again a yes or no. It did pop up, so hopefully that's a good sign. Were you able to implement any control measures? So not only did you analyze them, were you able to go and correct them or do some implementation of solutions? All right, looks like we've got pretty good responses there. And that's good. The majority of you were able to implement some control measures. And again, no is not an option. So if you're in that not yet category, we do encourage you to, of course, work on those. And if you have any interest in having us assist you, again, it would be at no cost. So if you just got some questions about how do we do, some analysis of our, meter records, our the way that we're charging people or doing corrections or do an audit of our finances, of our billings. Those are all things that we have done and can do, and would, be more than happy to help you guys with. Sometimes it's just, you plan on doing it, but it's kind of a back burner and you'll get to it one day. But maybe, that day should be today by letting us help you, so that you can, free up your time and let us do some of that analysis. So just keep that in mind, that we definitely want to help, you guys to make some progress with your apparent losses. So just a little plug there for, that assistance that's available. And there are lots of things that we can do that, we definitely want to be of assistance. All right. Now let's get into the topic for today. So today, since we are talking about real loss, we want to spend just a few minutes kind of refreshing the memories about what real loss is. And of course, real loss is that physical loss in the system. So if you recall, those losses are also called leaks. They can occur on the mains, they can occur on the service lines, and they can occur at the tanks. Real losses are calculated when using the audit based on all those other volumes that you enter. Since the real losses are calculated, they can't be broken down based on the water balance or the water audit. This is important for you to understand. The real loss value is calculated based on your inputs. So there's no way for the audit software to give you any additional information about that value. So just kind of keep that in mind, that it is a calculated value based on your inputs. And when you're in the audit software, the real losses are calculated at the bottom of the reporting worksheet. So that's where you find them in the audit itself. So let's take a look and see what's happening in Tennessee with real loss. So we received the Tennessee data as a whole. And the most recent data we've received is 2017. So this is a little bit dated, but things don't tend to change drastically from year to year. So here we're pulling out the real losses as a percent of the total losses. And you can see we've got a really wide range from the minimum of 12.6 to the maximum of 99.6. with an average of 89.2. So what that's showing us is that real losses are a big concern for some systems. A large majority of their losses are real. And for other systems, a very small portion of their losses are real losses. And then here is the range of the Tennessee real losses when we look at gallons per connection per day. And again, it's a very large range. So we go from just under that 1 gallon per connection per day to 230 gallons per connection per day. And so that the average there is 66 gallons per connection per day. And that average is more than twice the AWWA benchmark median for this key performance indicator. So that means for the average number of our systems are dealing with higher real loss than what the benchmark is based on AWWA's information. So some work for us to do to reduce real losses in the state. And then here we can see what the real losses look like in the dollars per connection per year. So we have, again, a wide range from just under $30 per connection per year to just over $370 per connection per year. And if you kind of think about those numbers, even at the low end of $30 per connection per year, if you've got, 1,000 connections, well, then you're looking at $3,000 that could go somewhere else. So, just even at the low end, that's dollars that add up. And then as we're talking about financial and what those values are, we want to spend a few minutes talking about how we value real loss. So if you'll recall, when we talk about non-revenue water, the water that's not making us any money, we do use different costs in that water audit software to calculate the value of the water that is lost. The apparent losses, the water we give away on purpose, is valued at the customer retail cost. The real losses, the physical losses, are valued at the variable production cost. So let's take a look at how those two are different. The customer retail cost is what the customer is actually paying for the water. And some of you have probably really worked to refine this number in the audit, looking at things like flow weighted averages for the various customer classes, and taking into consideration the sewer portion of the bill. If you haven't refined that number and you would like to work on refining that number, let us know. We do have a couple of tools that we can provide you to refine this value, and we can walk through those tools with you. The more accurate this number is, the more accurate the values in the water audit are going to be as well. And then the variable production cost, which is the number that's used in calculating the value for your real losses, is based on the costs that change when your utility produces clean water. So it typically includes the cost for electricity and chemicals or treatment costs. It can include things like wear and tear on the equipment, but we typically don't see that being included by too many systems, although it's perfectly acceptable to put it in there and make that number a little bit more accurate if you have that information. So there is an option to use the customer retail cost for all of your non-revenue water instead of using that variable production cost for real losses. So take a minute and think about it. Why might you want to do this? Why might you want to report the cost of real loss, the water leaking, at what the customer pays for it instead of what it costs to produce it? Why might you want to do that? So take just a minute, use your chat and chat that in.
I feel like I should be playing the Jeopardy music in the background. And your answer does not have to be in the form of a question.
Quiet then. So Chris says you would want to use it if you have a limited supply, and by reducing your real losses, you can then sell more water. So absolutely, that's a great example of when you would want to use the customer retail costs for your real loss value. But that does kind of bring up the question, right, of can you sell the water that you save? And the answer is not always yes, right? Because you're producing that water, it's leaking, and you may not ever actually get it to the customer and sell it. So there is, that's why there is an option there for you to toggle between. So Ricky says the real costs reflect real budgeting prep. That's quite right. So there are times when you want to be able to communicate the value of water in different ways. So it might depend on the audience as to who you're communicating with, the cost of the real loss. So if you're looking at, you're reporting what it costs to produce it, that's the variable production cost, and you would want to be able to use it for talking, budget issues and what you're actually going to save. But there also might be an audience where you want to talk about what that water is really worth to the customer, and it's running down the road, or it's running into a ditch, or wherever it's leaking to. So it might be dependent upon your audience as well. Tim is saying to be able to control your costs. That's absolutely right, because James likes to point out that somebody's paying for that water. Eventually, it has to be paid for. So eventually it is added to your customer's cost in some form or another. So being able to control costs, absolutely right. So good points. And that's why we wanted to make it obvious to you that you have the option to toggle between those two costs. And it does sometimes make a difference. It always makes a difference in what the value is that's shown for your lost water, for your real losses. And that is showing on the audit software in the dashboard. And the dashboard looks a lot different in the new version 6, but right now the state of Tennessee is not going to switch to version 6. So for now, this is version 5. And this is the dashboard in the audit, and it lets you look at non-revenue water in two ways: by volume, which you can see on the left, and by value, which you can see on the right. And sometimes those bar graphs look similar, and sometimes they don't look anything alike. So it really does depend on how you are charging your customers, if you're a purchase water system, those kinds of things. So just be aware that those tools do exist in the audit, and they can help communicate your water loss story. So let's go back and look at that water balance again. The real loss is the outcome of the whole balance, right? It's the calculated part that's based on your inputs for all those other boxes. And since that value is calculated, you don't enter a validity score for real losses, but every other input affects the validity of this number. So let's take a look and see how it does affect this number. So if any of your inputs is not perfectly accurate, I got some sketches on my screen there. James, I don't know if you have the ability to clear those or not, but if not, we'll address it. But I just saw that I've got some issues there coming up. So if any of your inputs isn't perfectly accurate in your water balance, the errors are going to show up in your real loss number. So if you undercounted your inputs, your volume from own sources, your water imported, then your real losses are going to be undercounted. But on the other hand, if you overcount your inputs, then you're going to overcount your real losses as well. Then if we look at the other side of things, if your outputs, your authorized consumption, your apparent losses are undercounted, then your real losses are going to be overcounted. Or the other way around, if your outputs are overcounted, your real losses will be undercounted. And hopefully these visuals help you understand what I'm saying here with overcounted, undercounted, and they kind of all blend together. But if you take a look at the images, you kind of get an idea. If we miss something and we undercount, it's going to undercount or overcount. It's going to impact our real loss outputs. And then, the number, if you have errors in your inputs and your outputs, your real loss will reflect those errors, and it could be going up with one and down with another. So the number that's reported in the audit is really only as valid as the data you entered. This is why you should really look at your data and assess its validity so that you understand what next steps are the right next steps. And again, the Southwest EFC can help to assess your data validity and make recommendations to improve it, so that you're comfortable, you're confident that you don't have too much of either one of these situations occurring within your audit. Then when you complete your audit, you can take a look at your water balance, and you can note that the water balance states that real losses are not broken down beyond the real loss volume. So you have to decide what you're going to do with that number, how you're going to react to that number. And if you're using the default values for apparent losses, that means that your real losses are based on some assumptions for apparent losses. And this free audit software wasn't meant to give you extremely specific numbers. It is one tool that you can use in your overall toolbox, but you have other tools in the toolbox that you can also use. And we're going to take a look at the breakdown of real losses and what some of those other tools are that we have today. So I'm going to turn things over to James now and let him walk you through a little bit more on real loss. James, I don't know if you're talking. If so, you're muted.
Thank you very much. I was. All right. Am I showing the right screen here?
Indeed.
All righty. So yeah, let's talk a little bit about sources of real loss. And by that, I mean, where in your system the losses are happening. Because even though the water balance doesn't break down the volumes, it does lay out, those basic categories of locations where losses can occur, and it's worth taking some time to think about them. First category is obviously breaks on your mains and transmission lines. And some number of main breaks are basically unavoidable over time. And catastrophic main breaks are often the ones that are the most spectacular sources of loss, and often the leaks that have the biggest impact on customers because of the significant effort that's required for repairs and the fact that you're often dealing with large quantities of water in compressed small amounts of time. But not everything surfaces. Small main leaks can be particularly difficult to find and deal with, particularly if you're a low density system, or for example, if your sources are very far away, or if soil conditions are just such that they prevent leaks from surfacing. Main leaks also include the category of hydrant and valve leaks, even though technically they're on appurtenances, not the mains themselves. For sort of auditing and audit adjacent analysis, these typically are counted along with main leaks. And some of them are really obvious, like this picture here, if they're near or above ground, but they aren't always. So when you're tracking this information, it's a really good idea to categorize, where, not only where in your system the leaks are happening, but if it's a leak on a hydrant and not on the main, that's a good thing to know, so that you can sort of categorize these different loss sources separately. Then there's the service line leaks. These are obvious, often less obvious. But it's really important to remember that any leak on your side of the customer meter is going to accrue to the utility, and there may be situations where leaks on the customer side actually accrue to the utility. And those are, if your system is one that has a leak repair rebate program, which many systems do, I know in Albuquerque we do, if your utility credits customers for leaks on their side of a meter after a repair is made, once that monetary credit is completed, that water is instantly transformed into non-revenue water, and it pushes that credit volume effectively into the loss column. So that's something to consider as well, particularly when you're gathering your information to fill out the audit. The third category is tank leaks and overflows. And they might be obvious, but they might not be. The tank you were looking at here happens to be in Alaska. It's got a 19-foot capacity, but it can't be filled over 16 feet because of system hydraulics and a new tank that was built a mile away at a slightly lower elevation. So this is one of those situations where knowing how things work in your system is very, very useful. This tank happens to be at Vandenberg Air Force Base. They installed this to replace an old tank that had been leaking long enough to actually raise the water table at that location. So when you're thinking about tank leaks and overflows, they're quite often not obvious. You have to think about your infrastructure. Some tanks are going to be built to channel leakage so that it can be recognized and quantified and addressed, but others aren't. And so, you have to, there are a lot of different ways to find out whether tanks are leaking, but you really have to sort of understand your infrastructure and determine what sort of level of effort you want to put into that. There's actually a fourth category of losses, which are losses in the production and treatment process itself. Which you have to count if those are inside your audit boundaries. It all kind of depends, if you're doing a source to sink audit where you're starting, maybe if you're a ground system at the wellhead and going to the customers, but you could also do an audit based on just the distribution system where you're starting at the output of the treatment plant. So whether you have to consider these losses for your audit kind of depends on your audit boundaries, but for the stewardship side of things, it's good to understand what's going on and keep track of these kinds of losses. They're often not talked about because they're typically very small in comparison to the other categories, but they are worth looking at. And I do want to be clear that this does not include water that is purposely used during the treatment process or disposed of. So if you've got an RO system, the disposed of brine is not lost. That's an authorized unbilled use. If you've got wells that you flush before you start pushing water into your system, that's also an authorized unbilled use. That's not real loss. It should be tracked, but it should be kept track of separately. But you might have leaks between your sources and your wells, and if you're starting at your sources, you want to consider that. But as Don said, the audit puts everything in one big bucket, and that's a great start because one of the main goals of the audit is to give you information about the magnitude of your losses, magnitude of your non-revenue water. So, how much are you giving away on purpose? How much are you losing to apparent loss? How much are you actually physically losing? But that's really just the beginning because the audit doesn't tell you anything about the sources of loss other than to acknowledge that they're occurring somewhere in your system. Again, that's okay. It's a first step. And the first step is deciding, that magnitude issue. Is your real loss significant enough in comparison to the other issues in your audit and the other issues facing the utility to be dealt with now? But if real loss is a problem, you have to understand it to be able to remedy it. And the audit's not designed really to provide you insight into those sources. Like many other aspects of the audit, you either have to have the data with which you can perform an analysis, or as is often the case, you have to decide how to develop the data to take that next step and dig a little deeper to identify those sources. I like to think of losses as kind of an iceberg. There's a lot that you can't see until you sort of look underneath. The devil is really in the details. So just to see if everybody's still awake, of the four categories that I talked about, and feel free to use the chat here, which of these do you think typically contributes the largest component of real water loss in a typical water system? Main leaks, service leaks, tank overflows, or production and treatment losses? Spot on, service line leaks. Yeah. Typically, those service line leaks are the biggest contributor. To quote the AWWA's M36 manual, in well-run systems, the greatest annual volume of real losses occurs from long-running small to medium-sized leaks on customer service connections, except when there's very low densities. And oddly enough, these are the leaks that often aren't really tracked that closely in many water systems. I mean, I've seen some very big municipal systems that have a big budget and a lot of money and are very sophisticated, and they don't track this information. So it's kind of a disconnect there. Potentially the greatest source of loss being the one you don't actually have much information about. So this is something to think about when you're considering the data that you track and your sources of loss, and what you track now and what you want to track going forward. So covered a little bit about sources. Let's switch gears a little bit and talk about types of loss, because sort of how the losses are happening is almost as important as where they're happening, possibly more important. In typical systems, you've got three basic types of leaks. My example here is going to be on mains, but there are analogs for service line leaks and tank leaks as well. A lot of leaks are going to surface. And there we go. Some are going to surface, and those are going to be categorized as reported leaks. They're the ones that are found because they show up on their own. The next question to answer is who found the leak? Was this something that your staff found moving around, or is this something that was reported in by the general public? That's another good piece of information to track, because it can give you an idea about how quickly you're finding leaks versus how quickly leaks are being found by other people. The second category, so that's reported leaks. The second category are the unreported leaks. And these are leaks that could be found if you were looking for them. So using proactive leak detection, maybe you're doing acoustic leak detection or night flow analysis or things like that. So these are leaks that are there. They're big enough to find if you're looking for them, but they're not surfacing on their own. And so these can potentially run for very long periods of time without being discovered. And last but not least, you've got the sort of background weeps and seeps that happen at joints. And these are typically unfindable and aren't reported, at least not findable using sort of traditional acoustic leak detection equipment, because they're small and continuous, and they just basically don't raise a big enough signal for you to track. Note that I did say traditional equipment. There are a lot of new technologies coming out all the time, and so satellite leak detection and things like that, that may make these a little more findable as we go forward. The other thing to remember is that there's often a continuum. Things can start out as background or unreported leak, and over time get bigger and bigger and eventually become reported. So even though these are distinct categories, there's a little bit of bleed over time and blurring between the edges. I think this graph demonstrates that very clearly. A lot of leaks start small and get worse over time. This is an image from a correlator showing the progression of a leak from mid-April to mid-August, and you can clearly see that the acoustic signature is increasing in severity over time. Another thing to note here is that post-repair here in late August, the signature is actually lower than it was at the beginning of things when the correlator was first put on. So this tells us a couple things. One, we know that the leak was running for at least 4 months, but in all likelihood, or 5 months, it was running for a significant period of time before that. And, this is one of those things where we don't have the full story here. It could be that this was just a random search and nothing was tipping them off until June here, when you had the spike that there was a problem, and then they waited a couple of months to get around to fix it. Or it could be that they actually knew there was a problem ahead of time. But the point here is that, we've got an idea of how long this leak was going on based on the correlator, but we know it started at some point before that. So every leak has got essentially 3 time periods during its lifespan. There's the time it takes you to become aware of it, either because it surfaces and somebody reports it, or you went looking for it. That could be short and that could be long. Then there's the time it takes to actually locate the leak once you know it's there. And then there's finally the repair time. The time it takes to isolate it and fix it once it's been found. So when we're thinking about this time frame, it's really all about the runtime. The real loss volume is going to be directly correlated to how long it runs. And we have to recognize that you can't recover everything. Leaks are going to happen. There's going to be some amount of sort of proactive work that you can do that's going to make it economically recoverable. This might look familiar. There's a similar graph in our apparent loss side of things. And here it's actually more reduction than recovery. There's going to be some low-hanging fruit that you can deal with economically. There's going to be some amount of loss control that you can do in an uneconomic way, by which I mean you might be spending $1 to save 90 cents. And there may be reasons to do that, you know, in view of a shortfall of supply, or maybe you're pushing up against state requirements. And then there's just some amount that's always going to be unrecoverable or unreducible, and that's okay. We're not talking about zero loss. That's impossible. What we're looking for here is an economically acceptable level of loss. There's really 4 mechanisms that you can use to reduce these losses or keep them economical, or what we like to call areas for action. The first of these is pipeline and asset management, which, you know, Don mentioned at the beginning. You know, real loss control and asset management really go hand in hand. They're kind of 2 sides of the same coin. There's active leakage control. There's the speed and quality of repairs. And then there's pressure management. So these are sort of the 4 broad categories of actions that you can take. And we're going to show you some case studies from each of these in the latter half of our session today. But the point here is that there are a lot of different things that you can do to address your issue, but you want to make sure you're using the right tool, because real loss control is not free, and it's often quite expensive. The audit gives you the magnitude of your losses, but you really want to be able to identify the nature and quantity and cost of those first before you jump in and develop a control strategy. You want to make sure you understand the problem, then develop the control strategy to deal with it. You know, and as Dawn pointed out, you know, that real loss number is what's left over after you account for all of your other inputs and outputs. So if you're using audit defaults for theft and systematic data handling error, and maybe you don't have complete testing meter testing data, you have to recognize that you don't have a completely accurate picture of what's going on with apparent losses, and that's going to reflect on the real loss side of things. You know, Don showed us those graphs about, you know, what different issues can do to the real loss, whether we're over or underestimating. So anyway, getting back to our opening discussion, you know, the real loss volume that the audit calculates is based on those other inputs. It's not going to be perfect. It's basically an approximation, and how reasonable that approximation is going to depend entirely on your other inputs. What you don't want to do is use bad data to get an incorrect view of what's going on and then apply the wrong loss control tools. You can kind of think about real loss as a sausage. Sure, you care about the sausage, but you also care about the ingredients. You know, what went into it, how was it made? And I know there's that saying that you should never see how laws or sausages are made, but I think with an audit, you definitely want to understand what went into it so that you can correctly interpret those results. And remember that the audit is the first step. It's not going to save water by itself. You've got to take action based on the results of the audit, and importantly, the additional analysis you do after you've got your audit results. And that additional analysis is really important. That being said, I've got this guy going downstairs instead of upstairs for a reason, because, you know, the audit creation and interpretation and analysis does get easier over time as you develop those processes to collect the information that you need and store it and analyze it and report it. So with that, we're going to shift gears here and get a little interactive and do a Google Jamboard exercise. Dawn, can you push the link out for us?
Why don't you explain it and I will pull it up.
Okie doke. So what we're going to do, and we've done this Jamboard thing before. I'm going to stop sharing this screen and move over to the other screen really quickly. Hold on one second. Apologize for the slight technical difficulties here. All right, so Don should be pushing a link through, and if you go through there, that link, you're going to come up to a screen that looks like the one that I'm showing on here, and we're going to talk about how you track event information in your system. Over on the left-hand side of your screen, there are some controls, and one of them looks like a little Post-it note. And so what we're going to do is have you guys click on those Post-it notes. A little note will come up here, and you can type your answer in and hit save, and it will show up on our screen here. So this is a way for us to essentially share information with each other about how and where you track leaks. And by this, I mean, what kind of systems are you using? Are you tracking leaks in a CMMS system? Are you tracking leaks in GIS? Do you do things on paper? Is your data collection process manual or electronic? We're trying to get an idea here of essentially how you collect that event data that you would then use to corroborate or refute your audit results, because the audit gives you that big real loss number, and there's sort of the next step is something called component analysis, where you basically take the information you have in your system and try to build the audit backwards. So can you look at your break information for service lines, tank overflows, and things like that, and build a volume that is reasonably similar to what the audit is telling you? So it looks like we've got a couple of people in here.
The link should be in the chat. You should be able to click on it, and it should open your internet browser right to where James is showing on his screen.
Yeah, so once you, here we go. Folks are coming on in now. So you can sort of ignore the presentation screen for now. We're over here in the Jamboard. So take a few minutes, and Tim, I can add that in for you. So Tim just put in their systems all PVC, so they track service line leaks with a handheld leak detector. That's exactly what I'm looking for. So I will add that in there for you and save you the typing. And feel free to do that as well. If you're having issues with typing in to the Jamboard, you can always just type your responses into the chat, and we can transfer them over. So Tim, in response to that, so you refer to service line leaks with a handheld leak detector. Do you track main leaks? And if so, how do you do that side of things?
So just a reminder, guys, you want to use that fourth icon on the toolbar that is the sticky note, and click on it, and then you can type in your response.
Yeah, and hit save when you're done. That's what puts it onto the screen. So information, hit save, and then you can click anywhere outside of that screen, and your response will show up. All right, here we go. GIS collector, walk the services, mostly in residential neighborhoods, listen for leaks. Track everything in Excel spreadsheet with details of pipe material, flow rate, duration, cause. Main breaks are in GPS, in GIS. Yeah, this is great. We'll leave it for another minute or two, see if anybody's like me and does the two-finger typing. Yeah, and these are all great. And the main thing, I think, the main takeaway here is, in general, it doesn't matter how you do it. The main issue is that you do it. If you have the ability to do your data collection or your data tracking electronically, That speeds things up considerably. It also helps make the data much more uniform. And if this is something that you're interested in looking into, maybe you're a system where most of this is done on a manual basis. We spend a lot of time helping systems do system mapping and event mapping. So as part of that technical assistance that Don was telling you about, that the state has provided, if you want to have some discussions about how to go about maybe switching a manual process to an electronic process, or what kind of equipment you could use, we would love to talk to you about that. By we, I mean me and our coworker Luke. We're very into this stuff. And it's often surprising, survey grade equipment can be very expensive, but we've helped small systems move sort of to electronic data collection for less than $1,000, including the equipment they need to do the data collection. There are some very inexpensive options out there, and there are actually, ArcGIS is the sort of industry standard, but it's quite expensive. There's free GS, open source GIS programs out there that are more than adequate for what a water system needs to do. So if you do have some questions about that, feel free to reach out to us. Okay, so it looks like we've got all of our responses that we're going to get here on how we track leaks. I'm going to shift gears here. Up here on the top, you can see where it says 1 through 4. You can click over to the next page, and I'm going to transfer one of the answers from our prior side over here. But here we want to get information on what kind of information you're actually collecting. So one of our responses from the prior screen talked about, flow rates and pipe diameters and pipe materials and things like that. So when you're out in the field, collecting information about a break, whether that's service line or tank overflow or mainline break, what information are you actually collecting? Is it something very basic where you're essentially collecting when it was reported and when it was fixed? Or do you go deeper into that, into the information and collect other attributes that could be useful? So I'll give you guys a few minutes to type that out. And I don't want to flip back and forth from the screen, but Don, if you wouldn't mind, maybe you could jump to our first screen and grab the attribute data off the one response
Sure
that
thing.
was included. So this is, what information are you actually collecting? And oftentimes, this is going to be, oh, here we go. Service line leaks and spreadsheets. So pipe material, flow rates, duration, cause, pressure, etc. Are there other things that your system collects? Do you collect a subset of what's showing there now? Are there other things that you grab?
And remember, if you'd rather use chat than Jamboard, you can do that too.
I've got your response, Tim. I'll drop that up here.
I was half a second slower than you, James. So you can delete mine.
Yeah, so time reported and fixed, location, supplies used to fix. Yeah, that's important. The supplies used is actually a really important piece, because that goes toward figuring out the cost of any repair. How much employee time did you use? How many clamps and bolts and various other things were used in order to facilitate a repair? Does your system actually know what an average repair costs? And there are quite a few that don't. And are you factoring everything in there? The water pressure, that's a good one that I've seen in a couple of systems. That's going to come into play in the second half when we're talking about tools to use. Yeah, all of this is really good information. Flow rates, when things are repaired, because if you're looking into trying to determine, how long things are taking, well, you need to know when it was discovered, when you actually got your crew out there, when it was isolated, because that really tells you how long it was running, because the repair time, if you're tracking till the end of the repair, there's a significant amount of time in there where the leak actually isn't running. So if you've got discovery time, isolation time, and repair completion time, that gives you some really good data points in terms of being able to estimate loss, but also being able to tell your customers what your average response time is, and being able to track that information internally. So good information. Last but not least, we're going to switch over here to page 3. And this is a slightly different question, but how do you decide where to do leak detection? And some of you guys sort of addressed this a little bit in the earlier question, saying that you walk routes and look for leaks. But when you're doing that active leak detection, whether that's bringing in a consultant or doing detection on your own using equipment that you own, how do you decide where to go? Is it you start at one side of the town and work your way to the other over a period of time so that you can hit most of the system within a period, or are you going to areas where there's problems? Is it random? So think a little bit about and share with us how you decide where to engage in leak detection activities. And these could be any type. We're not really concerned about the type of system or leak detection process you're using. We're just trying to figure out how you decide where to apply it. Tim, I'll put this in here, or Don, do you want to do that?
Sure.
Okay. So Tim added, they try to cover the whole system unless they've got a low pressure call. Yeah, low pressure indication that there's a leak somewhere there. So that's something that tips you off. Tim, if you wouldn't mind sharing, what kind of time frame do you try to cover the system in? Obviously, I guess some of that's going to depend on how big your system is. But are you trying to give the entire system a once over, every year, every 2 years? Known problem areas first, and then age of the services. I'll add that one in, Don. Great. So Tim says they try to cover the entire system at least once a year, and that's a really good idea, because that if it's economically feasible for your system, because you basically know that once you've cleared an area, it's clean. So you've got a maximum runtime for any given leak. Let's see, we've got location of historical leaks, age of infrastructure, soil type. Knowing that leaks might not surface in certain places, covering the entire system within a 5-year cycle. Okay. Oops. And Ricky, I'll add yours in, which is a combination of age of infrastructure, breaking up the system into zones, and leak detect the whole thing every 1.5 years. Yeah, so all of these are really good. And it sounds like most of you, or if not all of you, are collecting and looking at your past leak information to decide where to go. Unfortunately, or maybe fortunately, leaks are never evenly distributed throughout the system. It's quite often the case that leaks tend to cluster in specific areas. And if you're tracking that information, particularly location and frequency, you can really use that information to decide where you're going to do your testing. Because, if you're going through the entire system, every year, year and a half, and you're finding that certain areas basically just are coming up with no breaks, every time, you might shift your processes a little bit and say, hey, the leak prone areas, I'm going to do those twice a year. And those other areas where there aren't many leaks, maybe I'll do every 2 years or every 3 years until something changes. And this is, why we really push the idea of collecting that event data, particularly electronically if you can, and in an ideal world in a GIS system, because then you have not only spatial information and can see patterns, but you can also add that time element to see, where frequency is increasing, where frequency is decreasing, what parts of your systems are stable, so that you really can efficiently distribute those dollars. Because, while your crews are doing leak detection, they can't be doing something else. And if they're leak detecting an area that's known not to really have problems, it may be that their efforts would be better placed somewhere else, or maybe doing something entirely unrelated to leak detection. The point here is that it's all about having the information so that you can do that analysis and make those kinds of economic decisions. Because again, we're not trying to get to zero loss. That's impossible. We're just trying to keep it at an economic level. And what we're seeing here is very good information, and that it's basically not random. All of you guys seem to be using the information that you collect from your system to prioritize how and when and where you're doing that leak detection. And so, even though all this information is good, I would suggest sort of stepping back and looking at your leak detection efforts and the results of them over time, and every couple of years deciding, is the current process and the current time frame that we look at appropriate? Do we need to speed it up? Do we need to slow it down? Are there areas that we need to cover more, areas that we can maybe check less frequently because they're not problematic, so that you can sort of continually and on an ongoing basis refine how you're spending those leak detection dollars and do it the most efficient way possible.
So now we want to focus on the ways that you can control real loss. So what are these tools in your toolbox? So James mentioned there were 4 different categories of water loss control activities, and they were asset management, active leakage control, repair speed, and quality and pressure management. And there are different tools that you can use under these different categories, which are shown on the screen. And today we're going to highlight some of the tools that you can use to help with water loss control, but we do want to spend just a couple of minutes looking at each category and the types of tools listed. We want you to understand that each of these tools has a different time commitment and a different cost associated with it. So for those that take a larger investment, you need to be very confident that you do have a real loss problem before spending the time and the money to fix it. So again, that goes back to your confidence in your data that goes into your audit. So let's take a look at a few of these examples. So this tool called asset management is one of the best tools that you can use, as it's about your overall system management and water loss control becoming a part of your management plan. In asset management, you're trying to make data-informed decisions to figure out what to do, how to do it, and how to get the most cost-effective, efficient results for your utility. Water loss control can be thought of as a subset of that. So I'm going to show you an example of using asset management techniques to reduce real water loss. This example also shows that you don't have to just use your water audit as the starting point for water loss control activities that do indeed work and make a difference. So the background here is that this system has been spending about $5 million a year for pipe replacement, and it was having no impact on their break rates or their water loss volumes. So their solution was to really crunch the available data and to develop an asset management plan. So this example comes from the Albuquerque-Bernalillo County Water Utility Authority, and it uses pipe break data from long before they started actually water auditing. So what this map shows is about 15 years worth of pipe break data that was pulled from a wide variety of locations and accumulated and put into a map for the whole service area. And the material is color coded. We also have these 11 study areas that are boxed in red, and they're not as relevant to what we're discussing today, but a lot of times that question comes up, why are there red boxes? So those were study areas where we focused on doing some other work, but the colored dots here indicate the type of pipe the break was on. And you'll notice that most of the dots are yellow or red. And that indicates that the vast majority of the breaks are on cast iron and steel pipe. So if we filter all the other breaks out, we see that there's about a 50-50 split between the cast iron and the steel breaks. And seeing about half the dots are on steel and half are on cast iron, that may not seem like much of a concern until we understand the pipe distribution. So this map shows the pipe by type. And as you can see, most of the pipe is blue, indicating that it's cast iron. The red pipe is steel, and it only accounts for about 5% of the overall system. So 50% of the breaks were on 5% of the pipe. Now we can start to understand the issue. The steel pipe was breaking at 10 times the rate that cast iron pipe was, even though the cast iron pipe was indeed older. So what that means is that almost half of the system breaks were occurring on 5% of the system's pipe, the steel pipe. And knowing this, the authority was then able to change how they managed their pipe replacement program, beginning to focus on the steel pipe. And they used asset management to determine which sections of steel pipe should be replaced first, because they couldn't replace all of the steel pipe in year one of the program. So they wanted to really prioritize it to get the leakiest pipes out of the system first. And they use the asset management principles of prioritizing pipe using probability of failure and consequence of failure to help them determine what areas to focus in for pipe replacement. And this graph is showing the impact of that decision. So the asset management plan went into place in 2011, and by 2016, they had reduced their break rate by 45%. Without increasing the annual pipe replacement budget at all. So they continued to spend the same amount of money, but saw significant gains in their break rates. So not only that, but because they were addressing the most break prone pipe, there was a 5-year cost avoidance of about $9 million, which they were able to put to use in other areas. So that asset management technique was able to greatly reduce the number of breaks in the system by replacing this problematic pipe, which saved them real water loss, and it also saved them money. So with that money, they used it to replace their inoperable meters in the system. So they went from several thousand inoperable meters to a few hundred. And of course, your meters are your cash registers. So this decreases your apparent losses, and it brings in additional revenue. Not only did they do that with the meters, they were also able to start a valve exercising program as part of that savings. So you might say, well, what does a valve exercising program have to do with water loss? Well, first of all, if the valves aren't working properly, it's going to be much more difficult to make your repairs that you need to do. And you can actually have leakage problems at your valves. So as you're out there exercising the valves, you might be able to discover some of those problems as well. The next tool we want to talk about is active leakage control. Here you find hidden leaks by proactively looking for them. So we're going to start with the question, do all leaks surface? And the answer is no. Some leaks never surface, or they don't surface for a very long period of time. We did a study for a 2-year period where there were known leaks in the system and they weren't repaired on purpose. And we let them run for 2 years and they never surfaced. There was no visible indication those leaks were there for that 2-year time frame. So to identify leaks in your system, you have to look for them in other ways sometimes. If you don't, the leak may eventually show up, but it may be a catastrophic failure by that point where you have a major sinkhole or some other issue. When we look for leaks, we can reduce water loss and we can prevent catastrophic failures. Of course, it's easier to repair with a clamp than replacing a whole section of pipe. It increases the system integrity by keeping the system closed instead of having a hole in the pipe, and it increases the life of the asset. So we want to proactively look for these leaks. But we can always, can we always find the leaks through proactive leak detection? Well, the answer is maybe, maybe not. We don't want to have the mindset if we go looking for leaks, we're going to find 100% of the leaks in the system, because it's just simply not true. We can find leaks, but there's still going to be certain things that for various reasons we're never going to find. It could be based on the skill of the person who's using the equipment. It could be based on the equipment we choose to use. It could be based on the type of pipe. It could be based on the soil. There are a wide variety of things. And all of these things, will determine how many leaks we can actually find. So with acoustic leak detection, we have two basic options for doing a leak detection survey. We have active and passive. When we do an active survey, we're talking about a person who goes around and they use that specific equipment to listen to the various points in the system, listening for a leak. So they're listening through a hydrant or an isolation valve, and listening for that noise that the leaks make whenever the water's coming out of the pipe. There's also passive surveys where you utilize devices placed on valves or hydrants or meters, and they can be placed either temporarily or they can be more permanently in place. And the passive devices also listen for leak noise. So the two examples we have shown here are the ground mics and the correlators. When you're getting started in acoustic leak detection, you may start with a ground microphone. If you don't have a lot of money to spend, excuse me, you just want to get some simple tools, it can be pretty effective. It doesn't need as much training as some of the other tools, although you probably do still need some training to know what you're listening for. Excuse me. You need to know that the smaller leaks are louder than the larger leaks. You also need to know that some very small leaks you probably won't be able to hear at all. You also need to understand metal pipe transmits the sound better than plastic pipe, and a transition in materials can muffle the noise, along with if the trench if the pipe is enclosed in water that's leaked out of the pipe, that muffles the noise. There's lots of things that can cause you to not hear the leak or what you think is the leak. So the customer usage can sound like a leak. So if a customer is always using water, it can interfere with leak noise. So can traffic noise and electrical noise. And you should also think about the time of day and the amount of possible interference you will have when you're doing the leak detecting. You also have to think about where you can access the pipe to listen, at the hydrant, at the valve, at the meter. Are you going to have to do traffic control? Are you going to have to divert traffic? All that kind of stuff, so that you're connected to that pipe. And the system characteristics can actually impact whether you succeed or not. How much pipe you have in the system. So is it a lot of pipe or a little bit of pipe? How much do you have to actually go around and do? What's the condition of that pipe? What type and size of pipe do you have? So what material is it made out of? What size is it? And how many contact points do you have and how far apart are they? So with passive surveys, the device listens for the leaks in the middle of the night, and it typically kind of goes in a scenario like this. At 2 o'clock in the morning, I'm going to turn on and I'm going to listen. Do I hear a noise? If I hear a noise, I'm going to turn off and then turn back on again at 3 a.m. Do I hear a noise at 3 a.m.? If so, I'm going to turn off and then I'm going to listen again at 4 a.m. If I hear a noise at 4 a.m., I say, okay, I've heard a noise at 2, 3, and 4 a.m. So it's probably not usage. It's probably a leak. So I'm going to go into leak mode. And if I at 2 a.m., I didn't hear anything at all, I would shut down and wait until the next night to listen again. But if I do go into leak mode, then there's a person that's involved with a system that can get a device, put it in their car, and drive around to select the alarm signals, and then determine whether the alarm signal is a true leak by doing some further investigation. These devices do sometimes have false positives. They also can have false negatives. We've done some testing with the different devices that are out there, excuse me again, and they can find certain kind of leaks really well and other leaks not so well. So again, it completely depends on your system characteristics, like what we talked about before with the ground mic. And you have to accept that no matter what you do, you're probably not going to find every single leak in your system. A correlator is a little bit more sophisticated, and it's also more expensive, and you probably do need some training. But if you use it, it can really help you pinpoint the location of your leaks, even known leaks. So even if you're in the case where it's not a hidden leak, it has surfaced, but you want to get a better, more accurate location before you start digging, the leak correlator can be a really good tool for you. And as you can see here, what you try to do is put your two leak correlators bracketing the leak, and the leak detector listens for that noise. And based on how long it takes the noise to reach that contact point, it can fairly easily pinpoint where the leak is actually occurring. Again, how well this works depends on knowing the size and the type of the pipe, and knowing whether or not there's any change in material within that section. So if it's done well, you can really accurately pinpoint your leak. You can also have these leak correlator type devices that can be put in the field, similar to the passive leak detection equipment, and they can correlate overnight. So not only are they going to tell you you have a leak, but they'll tell you where the leak is. So you kind of put this net of these around an area, and then because they're all turning on at the same time and listening, they try to figure out where your leaks are and help you figure that out in one step instead of doing the two things separately. So here's an example, a real world example. This particular system is a fairly large system, and they do contract with an outside firm to complete leak detection. And this is active leak detection that they do on 1/4 of the distribution pipe every year. So the entire system is surveyed every 4 years. And when we first started talking with them, they felt like they were doing this a really great job by leak detecting their entire system every 4 years, as large as they are. But as we talked with them a little bit further, we did kind of realize that there were some pros and some cons to doing the entire system every 4 years. So they were able to see patterns and trends in the entire system, and the information can be put into GIS to show changes in the condition, indicating where the breaks are happening. So that gives us a lot of really good information. But this particular system can't always prioritize repairing all of the leaks that they find every year. So they're looking for leaks, but if they can't fix them, they're not really saving the water. So they might want to think about, slowing down a bit and doing less of the system every year so that they can get to those leaks and get them repaired. Also, since smaller leaks are louder, they're finding those smaller leaks early on, and that's a good thing because they can be repaired before they turn big. But the small leaks could be masking bigger leaks. And if, because the survey team only comes out once a year and they're only there for a couple of weeks, they don't come back and survey that area after the leak has been repaired. So they're not getting the chance to listen again to see if there are bigger leaks that are found after those smaller leaks have been repaired. Also, if they're repeatedly inspecting quite a bit of good pipe that doesn't have very many breaks year after year after year, it may not really be the best use of funds to continue surveying that pipe that hasn't been problematic every year. Maybe they should do it once every 4 years or some other frequency of time to kind of monitor its condition. But knowing that the pipe's in good condition can, help them reprioritize. So this is really a low cost efficiency. If you are doing your leak detection kind of randomly across the entire system, you're probably surveying a lot of pipe that you don't need to do because there's very few or no leaks on that pipe year after year. So if we were more judicious about where to do leak detection, you can do a lot less of the system, but probably find a similar number of leaks. So that was a, kind of an eye-opening discussion to have with the system, that maybe the way that they were doing it did have some pros, but it did have some cons, and maybe there was some rethinking now that they had a lot of good data on their system about how they could reprioritize that leak detection and really optimize it so that they could get the best use of their funds. So the bottom line here when you're looking for leaks is pace your work to match what you can actually fix, because the improvement in real water loss comes from fixing the breaks, not finding the breaks. You need to match the technology and the techniques to the system's specifics. Use things that will work well on the type of pipe that you have. Choose activities that meet the goals you set. We've talked about goal setting several webinars ago, and you'll really want to make sure you've got goals for why you're doing leak detection, and choose an activity that helps you meet those goals. Not only do you want to choose the activities that help you meet your real water loss goals, you then want to match your activities to that budget. What can you afford to do? So now I'm going to turn things over to James, and he's going to go through the last two examples of real loss water control.
Uh-oh. There we go. Sorry, my screen just did a blip there.
Yep. I was going to say, that's
everything went
an
fuzzy.
odd picture
really
we've got there, James.
Yeah, that was really scary. So next up is, improving the speed and quality of repairs, which is probably one of the more obvious methods of reducing real loss that we have in the toolbox. But there's the question of whether you can and whether you should. And of course, that only matters once you've actually found a leak. The faster you can repair it, obviously, the less water you're going to lose from that point on. And you may have visual clues that lead to that leak discovery, or there might not be. Your discovery might have been due to proactive leak detection, like we were just talking about, or maybe night flow analysis, or some other thing. But the question here is, how long does it take to repair a leak once it's known to exist? Is your system one that looks kind of like this, where the time to find leaks is relatively short, but repair time takes a long time? Is it maybe something a little more like this, where awareness and location is the issue, but once you've found something, or there's been a way aware of it, you actually repair it pretty quickly? Or is it maybe something a little more like one of these other scenarios where everything just takes maybe a little bit longer than it could or should? I'm going to continue with the presentation, but while I'm doing that, if you can sort of think about these four options here, and maybe use the chat to throw in 1, 2, 3, 4, which of those best matches the scenario at your system, the timeline at your system. And if none of them match, you feel free to put in a text of what your typical timeline looks like in a description. And obviously, this is really important, but and getting back to my earlier point about small, long-running leaks, here's a chart of some flow rates and durations, and what those turn out to cost you in real loss. And the thing that this really brings home, I think, is that those big gushers aren't really the problem when it comes to real loss volume. Typically, they're big, they get noticed, they get repaired quickly. It's those small, long-running leaks that lose more water than the big ones over time. And if you look at this, example here, our bottom category, a single leak is accounting for about a third of the water loss, assuming these are the only 5 leaks we have in the system, let's say, in a given year, which is probably somewhat unrealistic. You're likely to have a lot more of those small leaks than you are the big ones. So, just for the sake of argument, let's say we've got 20 of those in the system running for 100 days. We've just gone from, a couple million gallons to 14 million gallons, and that's just from those small leaks. But getting back to our initial table, if you can cut the the repair time in half, you cut the losses in half, at least the losses from that point where they were discovered. Now, of course, that's gonna save you a bunch of water, but speeding up response time is going to cost money. Nothing is free. So you really need to do a cost benefit analysis and see whether improving your response time actually makes sense for you. There's, the cost of water production that you have to deal with by not speeding it up. There's the cost of additional staff, additional equipment, maybe other additional resources that you need to speed that up. Maybe, part of what's slowing you down is not having the spare parts you need around. So you might have to invest in an inventory of spare parts that you can just grab off the shelf and run out and clamp things with. On the flip side, you've got the benefit of not losing water, not having to potentially deal with those catastrophic losses. If you fix things quickly, because sometimes, between the time you find a leak and they get around to repairing it, things are a lot worse. And then there's not just financial benefits too. You really have to think about, what we call the triple bottom line on the asset management, those social, economic, and environmental responses or benefits. So fixing leaks, potentially brings goodwill from your customers. Where our director lives in Rio Rancho, people are a little upset with the water utility because there's water running down the street all the time, and it makes them look bad. And people, sort of look at that wastage out here in the desert, and it upsets them. So, repairing leaks can build goodwill with the community, or at least reduce the bad will you get when people sort of see ongoing leaks running down the street and nothing apparently being done about them. So, you really have to determine, whether the costs outweigh the benefits, because just because you can do something doesn't mean that you should. Again, we're talking about economic levels of real loss and doing the right thing given all of your different priorities. And to know the impact and figure out those costs, you have to have the information collected about your breaks and your repair times and your response times. And that might not be in an easily accessible format, but usually there are things that can be done to that data to make it more easily accessible. And this, again, is something that we can help you with. This is an example from a project we worked on a couple of years ago in Gatesville, Texas. They didn't have anything in a GIS map. They had an order system, work order system that had break information in it, and they had some repair logs. And we were able to take that information and basically build them a map that not only showed where the breaks were happening, but also showed how fast they were responding. So you can see there's 3 different color dots here. The green ones are leaks that were repaired within 24 hours, yellow were repaired within 48, and anything red took more than 48. And so from this basically simple calculation, we were able to come to the conclusion that 34 of these 49 breaks, 70%, were getting repaired within 24 hours. And the slower repairs only accounted for about 18%. From that, we were able to build some cost estimates and be able to see what the impact of speeding up repairs would have. We could use some of this information and other data that they had to calculate flow rates, to look at losses. We could look at the work order system to figure out how much labor they were expending on this, and really do that cost benefit analysis to see whether speeding up repairs was going to be a good solution for their particular problem. So when you're looking at your break data and how you repair leaks, think about how fast you do that. Do you even know how fast an average repair takes? And once you figure that out, think about whether it can be improved. If so, how, but also consider whether it should be improved. Because again, you can't use all of the tools all the time. You have to be selective. And there may be other things that you can do that'll have a greater impact on your real water loss control. Our example here comes from Rio Rancho, as I was telling you, where our director lives. In this particular location, there have been 5 leaks over the last 6 to 9 months, and the utility keeps digging up the street and making repairs. And you can see the spot here is on top of recently repaved street. This is over a service line, and it's leaking again. And when you look at the surroundings here, we've got the upstream side of this, or the uphill side of this leak, where we've got all this scrub brush, and downstream of it, there's lush vegetation. We're out here in the desert Southwest, so vegetation is a sign that something that's going on underground, and the vegetation here lets you know that this is basically an ongoing recurring problem. They're fixing a break, and it's probably breaking within a couple of weeks of the repair. So this brings up the question of the quality side of things. Speed is one thing, quality of the repairs is another. If the repairs here were more long lasting, they might not have this issue. As it turns out, they finally made the repair, 7 days after that initial set of pictures was taken. So, relatively long runtime for the 5th or 6th time in a 6 to 9 month period. So this is one of those things where you have to think about the quality. They're keeping going back to the same place over and over again. And this is very typical in this system. And what they probably need to be asking themselves is not how fast are we making the repairs, but are the repair techniques that we're using appropriate? Or is it that we're using good techniques, but we're using good techniques on failing pipe? And in this particular situation, that's the likely scenario. It's probably polybutyl pipe. This system has a history of known problems here. And typically, once there's a break on one of these service lines, it continues to break. So in their situation, the solution is probably to sit back and think about what makes sense to do in terms of repairs. If they know anytime an initial repair happens that they're going to be back a couple of times in the next few months, maybe the solution is to just take that pipe out the first time there's a break and not do those ongoing repairs. And again, if you've got the information, you can do the cost benefit analysis and say, okay, well, it cost me a little bit more up front to actually replace the line, but then I've got the cost savings of having to come back 3, 4, 5, 6, 7 times in a year. Assuming that you're tracking that information. And you've always got, those options to think about in the back of your mind. You can repair things, you can rehabilitate them, or you can replace them. And you really should keep all of your options open and really look at the big picture of what's going on when you make those decisions, because sometimes the more expensive initial decision is the right one in the long term. Our last category we're going to talk about here is pressure management. Essentially reducing peak pressure and overall pressure in your system. The system that we're talking about here is one that we worked with in the East Coast. They're in a mountainous area. They've got significant elevation changes, and they purchase water from a regional treatment plant. And this system has to pump water up a bunch of mountain ridges. And when their system was built, and to sort of keep costs down, they tried to minimize the number of pump stations that they need. The flip side of that is that they have to maintain very high pressures so that one pump can push water over multiple ridges. And because of that, the system typically sees pressures exceeding 200 psi throughout the system. And in some locations in the lower elevations, it's actually closer to 300 psi. The system also has over 50% non-revenue water. So that, one of the issues that they're having is that these high pressures are causing lots of losses. And we know that there's a direct relationship between system pressure and leakage, as these next 3 pictures demonstrate very clearly. It's 3 pictures of the same break. This is at a very low pressure. It's just kind of dribbling out, jacking the pressure up a bit. We get a lot more water coming out. And if you at a high pressure, this basically is turned into a gusher. So for this particular system, they can reduce their real losses by reducing operating pressure, but they've got to balance that with the costs of pumping that water. So, they've got the cost of purchasing water that they're then, losing through these leaks. But if they're going to address this, that means adding new booster pump stations and maintaining them over time, which also is a cost. So like everything else, cost benefit analysis is kind of required here. And they need to see, whether reducing pressure is a useful solution for them or a workable solution for them, and decide which route to take. Because when they have failures, they tend to be catastrophic because of the very high pressures that they're working on. So, high pressure obviously is going to lead to more breaks and more water loss in all 3 categories that I talked about. The background leakage is going to be higher. Those unreported leaks are going to be higher, and the leakage from reported breaks is going to be higher. If you can lower your pressure, it will have a net positive effect. The water loss will go down even with the same number of breaks, and there's a very good likelihood that you will have fewer breaks. If you're interested in trying to figure out, well, if I lower my system pressure on average 5 psi, or maybe do that in a certain part of the system, what is that going to benefit me? One of the KPIs in the water audit, one of the more esoteric ones, is actually a loss per connection per pound of system average system pressure. This is in the audit, and it's a calculation that you can do. And this example here shows you approximately the net impact of a 10-pound reduction in pressure from 65 to 55. It's a little over 4.5 pounds of, 4.5 gallons per connection per day that would potentially be saved. This is not perfect. It treats this as a linear equation when it's not in real life, but for planning purposes, it's really useful. So, if you're looking at what a pressure reduction might do for you in terms of reduction in real water loss, the audit actually has a piece built in that you can use for that. The other thing you have to think about with pressure, and particularly pressure transients, is your system was built to handle a certain range of pressures. Let's say we've got a newly installed main and the failure pressure is somewhere around 150 to 200 psi. You're going to have pressure transients and surges, or even higher than normal pressures periodically. And when it's new, the pipe's going to handle that. But over time, that pipe's going to be impacted by things like corrosion and traffic loading and ground movement and temperature swings. And as you continue to have pressure surges, your system is going to be less capable of handling those. At some point, the failure pressure might drop down to 70 or 100 psi. So this is another good reason to sort of collect data and have a hydraulic model of your system so that you can track pressure in the areas where breaks are happening, because that is really useful information, because you can use that information to track those transients and try and reduce them, and decide, how you're going to do your pressure optimization. So, if you know what the pressures are and areas where things are consistently breaking, you can use that information to see whether it's possible to maintain average system pressures that are lower than that, and use that information to try and reduce pressure surges. Because if you don't address pressure issues, if your system has those, your break rates are guaranteed going to increase over time if you don't do anything about it. And even if you don't have a problem with breaks due to pressure transients and things like that, think about pressure optimization. If you can lower pressure in some or all of your system, it is definitely going to impact your non-revenue water. It's going to lower your repair costs. It will probably lower your energy costs as well, and can have positive impacts by allowing you to defer asset replacement. So think about, are you optimizing system pressure? Is this something even that's on the radar? If it's not, can you reduce it? Because even a small reduction may help you over time. So we've got about 7 minutes left. I'm going to do a quick run through on some internal metrics. The good thing in our Jamboard exercise, we saw that you guys were collecting lots of information about events, and that is really good. We're going to talk briefly here about, what do you measure, what could you measure, and what should you measure. And this basically takes us full circle back to the beginning where we were talking about goals. And I want to point out that despite the state using percentage metrics for their minimum autumn requirements, your internal metrics shouldn't just be those. Those percentage metrics are actually better avoided because they don't really give you an accurate picture of what's going on year over year. So if you focus on non-revenue water as a percentage of supply, for example, and nothing in your system changes year over year, but your customers start conservation and use less water, your consumption is going to go down, but the end result is that your non-revenue water is going to go up because it's going to be a bigger piece of that big puzzle. So it's better to focus on metrics like, real loss per connection, because those metrics aren't going to be impacted as much by conservation efforts or changes in system size, for example. So, track those metrics on real and apparent losses and track the information that goes along with them, and recognize that those Tennessee audit requirements there are only two: the data validity score of 81 or more, and an upper reach of 20% non-revenue water by cost of operating system. Those requirements are focused on financial accountability, and simply meeting those really isn't going to drive water loss control. And if you think about it, 20% is effectively the ceiling. They've designated a non-revenue water ceiling that you can't go above. But if you're meeting that, wherever you're at is arguably the floor. Once you've made that initial cut and you're below 20%, what are your incentives to continue to reduce non-revenue water and real and apparent loss in particular? And what should your target be? And that's something you have to decide for yourself. It's really important, I think, to say, not just say, well, we met our audit requirements, we're good. That should be fine, because again, the state's requirements are focused on financial accountability, and that's only part of the picture. You want to be a good steward of the resources that you have. And I'll give you an example as to why not to just use those requirements as your targets. This is a system that we recently worked with that actually does very well in the real water loss category and non-revenue water category. It's about 6.3% of the total volume is non-revenue water, and it's about 1.2% as a cost of operating the system. So their real loss number is roughly 950 acre feet per year. Remember that number. I played with the input numbers to figure out how bad things would get to trigger the state board review, and it's actually really, really bad. You could actually push the loss up to almost 78,000 acre feet and still come in under that target. Now, obviously, I stacked the deck a little bit here. I just increased the system input, and you would expect costs to go up a little bit as well with that. But the point I'm trying to make here is that you can do really bad on the real loss side of the equation and still meet that 20% NRW as a cost of operating your system. Just meeting those requirements is not going to drive water loss control at anything more than a very basic level. You've really got to identify those problems and take action. And, the comptroller and the boards aren't really there to tell you how to decrease that non-revenue water or how to decrease your losses. They provide you some guidance if you fail to meet the requirements, but what TDEC wants you to do is really understand your water loss and better control it. And that's what this program is really about and why it exists. The need for water loss control is clear, and what we're trying to do here is provide you some of that how-to and assistance with what to do about it once you find it. So just don't focus on your real loss goals. Also, think about them in the context of your loss control program and related goals, and try to be comprehensive about it. The audit is step one, but you really have to go further than that. And most of you seem to already be doing that. Track that event data. Think about the questions you want to ask and whether the data that you collect helps you answer them. It's really going to help you see those patterns, identify the losses, so that you can make the appropriate adjustments and apply the appropriate tools. The currently favored metrics for version 6 of the water audit are not those percentage metrics. Those have really been phased out. So for your internal view, I recommend highly that you switch to this kind of a metric if you haven't. They're looking at unit real losses in terms of gallons per connection per day, or for less dense systems, gallons per mile per day, both for real and apparent losses, and then a combined number for total losses. And then also looking at the cost rate for those. So, what is the dollars per connection per year for real losses, for apparent losses, and total unit losses, because you really want to be able to look at all of those to decide which is more important to tackle first. As Don pointed out, sometimes there is a disparity between the volumes and the values, and you want to make sure that you're attacking the right thing the right way. Obviously, there are a lot of other internal metrics that you can keep. Those are going to be situation specific, and you should really think about your needs, whether you keep information about events and locations and duration so that you can track response times. If theft is an issue, you might want to keep metrics on instances of identified theft. Identify the lost, a recaptured lost revenue. Those avoided costs. It's important to know what those are. Think about your supply conservation. You may want to keep metrics on that. repair time, impacts, repair costs, all good information, all good, useful internal metrics, all of which will help you with not only real loss control, but asset management if you go down that road. And we highly recommend you do. And obviously there are many others that's going to be situation specific. The goal here is to, again, get goals that fit your system and collect information and apply tools that fit your particular situation. The toolbox is a great place to start. We've gone over a couple of the options there. There are many more tools available. If you haven't visited our website yet, I highly recommend it. It's swefc.unm.edu. We have recently unveiled water loss control switchboard there. I think we have 54 different tools up there right now and resources, manuals from a variety of different states, lots of different tools that you can use to both categorize and address your real losses. One of which, if you've got a lot of break data, is this break rate index tool that we have, which you can use if you've got information about the frequency of breaks and the materials that those breaks are happening on. You can input that data and see how your system breaks compare to national averages on a material-wide basis. AWWA uses that 0.2 breaks per mile per year as kind of a catch-all, but everybody's system has a different pipe makeup, and that has a big impact on your break rates and what they should be. This is an example here. This shows basically the index. It does a weighted average calculation based on those average break rates that are out there from a couple of Utah studies of about 15% of the pipe in the country. And it gives you a score for the system as a whole down here. If your score is 1, that basically means your system is breaking at the national average. If it's less than 1, in this case, it's 0.68, it's breaking at, about 2/3 of the national average. If it's higher than 1, it's breaking it 2-3 times. And you can see in this particular example, most of the pipe is doing really well, but their steel is breaking at almost 18 times the national average for steel breaks. So this is, one of those tools that you can use completely separate from a water audit to sort of hone in on which materials in your system are causing you problems to, help you start taking some specific action and help to target your action. There's also the real loss component analysis. This is another tool that is designed to help you categorize your losses based on break information that you collect, so that you can take that, water audit magnitude, big picture, and start breaking things down. This is a relatively complicated tool to use. We have a lot of experience with it. If this is something you're interested in looking at it, please reach out to us. It actually hasn't been updated for a while, so it's running on an older version of Excel, and not all of the features work with the modern versions, but we've got some computers with old versions of Excel on, so we can help with that. So that pretty much wraps up our presentation for today. We hope it's been useful. We've got an applied activity here that for this case is a survey, I believe. And I'll turn this over to Don, and then we'll open up the floor to any questions you may have. And I'm going to throw our contact information up here. Heather wasn't able to join us today, but her information is there as well. This program goes on for quite a while, even though the training portion is concluding with this session. The technical assistance piece is available to you. Again, it's free. The state has made that available for you. We would love for you to reach out to us and let us help. That's what we're here for.
All right, so today, since we won't be able to join you again in another technical training session, since this is our last one in the series, we wanted to get your feedback. Instead of doing it at the beginning of the next training, we want to get it at the end of this training. So whenever you're done with the session today, immediately a survey should pop up in your Internet Explorer or whatever internet access you use, and it's just a quick survey, kind of like the poll questions we did at the beginning. we'd really like to just get some feedback from you guys on your real loss and where you're at in that process. So if you'll take just a couple of minutes and complete that survey for us, we certainly appreciate it. Also, we want to be able to offer you tools and resources that would be helpful to use, thus the survey. So as soon as you're done with this, a screen should pop up. And if not, you can let me know. I can send it to you separately, but hopefully technology works for us and the survey will pop up right after. We are a few minutes over, so I know that everyone's time is very valuable. We don't want to keep you around. If you do have questions for us, James and I will stick around. We'd be happy to answer them. Or you can feel free to email us at our contact information here with any questions you have. If you don't have questions, feel free to go ahead and click that end button and leave at this time. Thank you so much for your participation today and in this overall series. We hope that you found it valuable, and keep an eye out for emails of what's coming with the remainder of the program. In probably mid-October, you should be getting some information. Thank you once again. Have a great day, everybody. I should say, if you do have questions for us, you can feel free to chat them in, or go ahead and unmute yourself and just ask us the questions you have, and we'll do our best to get you some answers.
Hey, Don, can you hear me?
I can. How are you, Chris?
Good. How are you doing?
Doing good.
Hey, great job on the workshops. Y'all did a great job. Did you get the question I put in the chat box about the AWWA 2020 benchmark you mentioned?
I don't see it. I don't know why.
Here we go. Stated that the 20 benchmark is about half of the Tennessee average. Is this source from the validated set in version 6? It is actually from, they're always a year behind. So I believe that's from the validated set using version 5. So the 2020 benchmark, the version 6 came out at the end of 2020. So it should be using version 5.
Are you saying that AWWA has set a benchmark?
No, they're not setting a benchmark. They're basically showing what the benchmark is from that data set. You know, they're not saying this is the number that you should be hitting. Those are the benchmarks essentially from that data set. So that was, I believe, the median data point from the,
Okay.
You know, and this is actually, you know, it brings up a very good point. One of the nice things about the audit is that it's a one size fits all, but that's also a downside too, because you're using it for systems, you know, with a few hundred connections versus, you know, a few 100,000, and different types of systems as well. And one of the improvements that they made to version 6 is there is more information able to be input about the type of system you have, the size, you know, what sort of population you are serving. So I think in future years, as they collect, you know, a larger and larger data set with more and more systems of different sizes, I think they'll be able to put out multiple benchmarks. This is something I talked to Will Jernigan about, who's you know, on the loss committee, and you know, they have to see what kind of responses they get, but that's definitely on their radar, you know, being able to provide some comparisons that are maybe a little more apropos to different size systems, because right now it's really kind of the validated audits in one big bucket, and it doesn't really account for those differences in size or differences in pressure and things like that.
Right, and but you're saying the median for that data, and you're comparing it to the Tennessee average. You know, working in the compiled Tennessee audits for a number of years, the Tennessee average is higher than the Tennessee median.
Yes.
Okay. Okay, I just want to make sure you weren't trying to put something out that says, hey, this is the benchmark. In general terms, people might think of a benchmark as a target to get to, which
and that is, you know, that's an issue, I think, with the way the AWWA's information is put out. They call it benchmarks, but it really isn't. It really should be sort of, you know, the data set median or the data set percentiles. You know, obviously the goal is to get as low as you can, but and it, you know, it's always system specific. And that's also something that just because even if there is a target out there, that doesn't necessarily mean that it's a target that is suitable for your particular system. And with the water audit, this is one of the issues that I personally have with it, is that it's all sort of put into a pile, and there is more effort made to do sort of cross-system comparisons, whereas I think because systems are so different, and because the sort of available data set of validated audits isn't that big, I think it's better as a comparison to yourself year over year. And that's why we focus so much on the goal side of things at the very beginning, because the idea is to sort of figure out where you are and where you want to be, not necessarily one of those sort of keep up with the Joneses kind of things, just because a system next door may be doing better or worse. Some of that may just have to do with their system specifics. They may be an older system, a newer system, a more leak prone system, have higher pressure, etc. So it's those sort of system to system comparisons are useful, but I think it's more important to compare to yourself year over year and track your own progress.
Thank you, appreciate it.
No problem.
Hey, James, Chris did some of the presentations at NAL in Nashville the last time, so
right.
He's pretty knowledgeable on the audit, I would say. His system has DMAs and very, very knowledgeable on water loss. So Chris has lots of experience and knowledge, and I learned from him when we were at the NAL training last time. So, but Chris,
well, find him at the next one.
We have requested the audit information for the more current years from John Greer at the state. But I haven't received anything yet. So if you're doing analysis and you have, better information than us, by all means, we'd be happy to update those numbers. But we're waiting on data at this point.
Actually, John actually sent that to me, I think yesterday or the day before.
Oh, yay.
I'm actually on leave right now, so I haven't been checking my email that closely, but I did see that. And so we do have that data. I haven't had a chance to look at it and see how complete it is, but I believe in his email, he indicated he had through 2019 or 2020. So we should be able to, and maybe when we send information out in October, we can include those updated metrics and see where things have gotten to more recently.
Good news. All right, I see we still have a few people hanging on. Any other questions for us?
I think we're probably good to go.
I agree. So let's go ahead and end this session. Have a good day.
Thank you. Bye-bye.